Hey guys, this is Miss Smith. This is week 5. We're going to continue talking about complex numbers, and today's lesson is going to be on multiplying complex numbers. So I know the first video from the week was just adding and subtracting complex numbers, so it was really just a matter of thinking about combining like terms. But last week we talked about this idea of if you have the square root of -1, it's equivalent to what we call I. So anytime there's a negative under the square root, we can pop that out as an I. What that allows us to do is if we take this and multiply it by itself, we get basically I squared equaling to -1. So this is boxed because it's going to be a huge concept that we'll use throughout these examples that we go through today. So basically every place and every time we see an I squared, we're allowed to replace it with or substitute in a -1 because they're equivalent. So if we look at example 1, it just looks like hopefully a typical distribution problem, except we have this idea of complex numbers involved. But if we do it like we would before and we just distribute this -2i by multiplication to both of these terms inside, we'll get -2 times 5, which is -10. And then, of course, we have the I there. And then we have a negative times a negative. So a negative times a negative is a positive. 2 times 4 is 8. And then I times I is I squared. So usually in the past, we'd be done there. But since we know that I squared is equivalent to -1, basically all it does is it changes the sign of this term. I'll show you how I plug it in and why that happens. But if we replace I squared with -1, this just becomes -10i, that stays, and then 8 times -1 just becomes -8. And then this is your final answer. So you have -10i minus 8. Because this has an I and this doesn't, we obviously can't combine those. Okay, so that's how you do that substitution for the I squared. If we increase the challenge a little bit down here in example 2, notice we have 2 binomials or 2 complex numbers that we're multiplying. So when we do this, we can do distribution property again, which is essentially what we do. We can do a double distribution, or we can use the box method if you guys remember the box method from before. So I'll start out with the box method. So same as before, if we put one of these and the sign that goes with it up on the top, and then the other complex number and the sign that goes with it on the side, then we just obviously are going to multiply all of the outside pieces to get our insides, and then we'll combine like terms on the inside. So we get 2 times 3, which is 6. Remember, this just gives us an organized way to do the multiplication. 2 times 7i is 14i. 3 times -4i is -12i. And then we get a -4 times 7, which is -28. And then obviously I times I again is that I squared piece. Remember then once we get our inside pieces, we can add them all up. So if we write that out, this is what it looks like. It's 6 plus -12i plus 14i minus 28i squared. And notice these guys right here are like terms. So we get 6, -12, and positive 14 is going to be plus 2i. And then again, this is where we substitute in that -1. So we get -28 times -1. 6 plus 2i. And then this becomes -28 times -1, which is positive 28. So there's a few more steps involved with this type of box because of the substitution of I squared equaling -1. And then notice here, we're still not done because these are like terms. So 6 plus 28 is 34. Sorry, a little slow on that. And we get 34 plus 2i as our final answer. So there is another way we could do this type of problem. So if I take the same problem, 3 plus 7i and times 2 minus 4i. We can look at it as a double distribution. Sorry. Okay. So if we take the 3 and we distribute it to both terms in the other complex number, we get 3 times 2, which is 6, and 3 times negative 4i, which is negative 12i. And then we do the same thing with this other term, the 7i. We distribute it to both pieces or terms in the other complex number. So 7 times 2, which is 14i. And then 7i times negative 4i, which is negative 28i squared. If you guys notice and you look, the same 4 terms we get here are the same 4 we got when we did the box method. We're doing the exact same thing. It's just a different process, and whichever one makes most sense to you, use it. If the box is easier to organize your thoughts, then go ahead and do that. If this seems a little bit simpler, then that's fine too. But we still have to go through the rest of the problem. So we're combining these like terms. Negative 12i and 14i is 2i. Remember, we're replacing the I squared with a negative 1. So we get 6 plus 2i, and then this becomes plus 28. And our final answer is the same, 34 plus 2i. Okay, so that's one of the bigger examples that we can go through. I'm going to do a couple more real quick. I'm not going to do both ways. I'll do one box method and one double distribution, just so you guys can see each, and have a few more examples to look at. Okay, so the next problem, example 3. So it says negative 5 plus I times negative 5 minus I. So if we do the box method here, we can draw our box. I'm going to put negative 5, positive I on the top, and then negative 5 and negative I on the bottom. Just make sure when we're doing all of these, whether you're using the box or double distribution, that you really pay attention to your signs. So negative 5 times negative 5 is 25. Negative 5 times I is negative 5i. Negative 5 times negative I is positive 5i. And then we have negative I times positive I, which is negative I squared. Again, usually this diagonal is your like terms, but if you notice here, some of you guys don't want to write everything out, that's okay. You notice that 5i and negative 5i are opposites, so they cancel each other out. So really the only two pieces that we have to add together or terms are 25 plus negative I squared. Well, 25, this negative doesn't go anywhere. It's like a negative 1 that's there. And then remember, we place the I squared with a negative 1. And so we end up with 25. This is going to give us plus 1, or an answer of 26. So that's a pretty unique example where we have conjugates. These are what these are called up here, and it ends up working out to just a number answer. All right, last example. Okay, so this one will actually probably be the easiest example because it's all positive. Notice there's no negative signs involved. And I'll do this one double distribution. So we get 2 plus 8i times 3 plus I. So we're going to take the 2 and we're going to multiply it by both of the terms in the second complex number. So 2 times 3 is 6, and 2 times I is positive 2i. Then we're going to take the positive 8i and do the same thing. So we get positive 8i times 3, which is plus 24i, and then positive 8i times I, which is 8i squared. Again, you guys will notice usually that these middle two terms are like terms. So we get 6 plus 2i and 24i is 26i. And then remember, we replace I squared with negative 1. So we get 6 plus 26i, and this becomes a minus 8. So then we have 6 and negative 8, which can be combined. So we get negative 2 plus 26i as your answer. Okay, so hopefully those examples helped you guys. The practice problems are pretty similar to these examples we went through, and then hopefully the formative assessment and weekly quiz, you'll see problems that are similar as well. All right.